Okay, so we're going to move on with our discussion of climate change agreements to talk about some of the agreements that have been set for carbon dioxide emissions and other greenhouse gas emissions reductions, and some of the groups that you might hear about when you're hearing about these treaties. We'll talk a little bit about where we stand right now with emissions and what has happened recently, both in the US and globally. So the two main groups that you might hear about when it comes to reducing greenhouse gases and international agreements are the IPCC, which is the Intergovernmental Panel on Climate Change, and the UNFCCC. This is the United Nations Framework Convention on Climate Change. And so IPCC is essentially a group of scientists. These are reports that are written by scientists that are meant to synthesize all available research on climate change and expected impacts for given pathways. Essentially, if we emit tons of CO2 and other greenhouse gases, what will happen in the globe, in the climate system, the oceans, land, atmosphere, or if we reduce emissions drastically, what will happen then? So trying to both bring together existing understanding of impacts and links between greenhouse gases and temperature increases and ocean acidification, but then also projecting into the future for given policy pathways. So the IPCC was established in 1998, and the first report came out in 1990. This is the first assessment report, AR1. You'll often hear these reports referred to just by their number, so AR1, AR3, etc. Now the UNFCCC was adopted in 1992. This is the sort of agreement by the United Nations to address climate change. And this has been ratified by 197 countries, including the US, and it established an annual conference of parties, the COP. You'll often hear about COP 22 and COP 27 or whatever, to discuss greenhouse gas emissions. These meetings can feel frustrating in that, every year people are getting together and meeting to talk about, the same stuff they've been talking about, but there have been real impacts that have come out of this. So the first greenhouse gas emissions reduction treaty was the Kyoto Protocol. This was initially adopted in 1997 and then entered force in 2005. Now there were some good things about this in that there were not only emissions targets for countries, but some of them were binding, but a lot of countries didn't sign on, including the US. The US was not a party to the Kyoto Protocol when it entered into force. But it was a first step, and I'm firmly a believer in don't let perfect be the enemy of good, right? We need to start somewhere. So there have been, since that first AR1 in 1990, there was another report in 95, AR3 in 2001, AR4 in 2007, AR5 in 2013. And then we had the Paris Agreement, which was another emissions reductions treaty. This had the explicit goal of preventing a 2-degree centigrade increase in global temperatures since pre-industrial times. Now, it still had in there, the goal is still to try to keep temperature increase below 1.5 degrees C. You'll likely have heard about that as a target that people are trying to reach. Realistically, I don't think we are going to do 1.5 C, but the closer we can stick to that and the less time we spend over 1.5 degrees, the better. So Paris Agreement had the goal of a 2-degree increase, and these were emissions reductions targets. They were not binding commitments, and they were still not strict enough to actually reach the goals of 2 degrees C. But again, they represent an improvement, and at these agreements, this is when people sort of come together and see what actually can be done. And so there's recently AR6 just came out in 2021, 2022. And so, it's easy to get discouraged by this over 3 decades of work on this, but there have been changes both in emissions and in our scientific understanding and sort of ability to say definitively what's going on. So If you look at just the language that has been in these assessment reports, back in AR1, in the synthesis, there was the statement, there is a natural greenhouse effect which already keeps the Earth warmer than it otherwise would be, right? So they're basically describing the fact that there is the greenhouse effect, which is why the Earth is habitable and not this frozen rock. And they say emissions resulting from human activities are substantially increasing with atmospheric concentrations of carbon dioxide, which will enhance the greenhouse effect, resulting on average in an additional warming of the Earth's surface. So, they're hedging a little bit. They're not saying that we are causing warming right now. They're saying that what we're doing is something that will enhance the greenhouse gas effect, and overall that should warm the Earth's surface. So it's a little bit equivocal. Now, if you fast forward to the AR6, now in the synthesis statement, they say human activities, principally through emissions of greenhouse gases, have unequivocally caused global warming, with global surface temperature reaching 1.1 degrees C above 1850 to 1900 in 2011 to 2020. High confidence. So they've started attaching confidence ratings, how confident they are, to different statements. So there are some aspects of the science that are less confident, but the link between human emissions of greenhouse gases and global warming, very high confidence, unequivocal. So that improvement in the certainty from a scientific perspective then also allows politicians to say, okay, well, I guess this is something we really need to deal with. Obviously, not everyone does that, but it does provide that opportunity. So where do we get our energy from? So these are figures showing the percentage of total energy consumption by source for both the world in the upper panel here and the US in the lower. And overall, see some differences, but largely, oil, coal, gas are very important and have been for a long time. Those percentages overall are decreasing with time. You have nuclear and hydro together make up a bit over 10 and 11% of total energy consumption, or source for energy consumption. So not insubstantial, but not likely to grow much in the future. Now, renewables, 5.8% globally, 7.5% in the US. Those are pretty small proportions, but they have been coming up quite rapidly. So that's good. When you think about the sort of long time that we've had these different IPCC reports over, starting back in 1990, it's been slow going. I'm hopeful that there'll be a lot more change in future years, but it's been slow going. So overall, right now we're at in the U.S. 7.5%, world about 6% of energy from renewables, and that needs to go up a lot. If the goal, especially, is to move to a world that's powered more on electricity than fuels you combust directly, then that's got to go up a ton. So, some progress, but a long way to go. If we look at actual total energy use over time, here, it's been going up pretty steadily for a long time now, even as you increased the proportion of renewable energies. You see this dip here that was from COVID-19 and the sort of really strong hit to modern economy that happened, and as people really weren't doing a whole lot. Even all of that, though, I think it was about an 8% reduction in energy use. So really big impact, but still kind of small. But energy consumption is going up. One interesting thing is that the energy intensity, essentially how much energy we use for a unit of gross domestic product, basically how much energy we use to do stuff, that has been going down over time. I think that's very encouraging. Essentially, you're decoupling increased prosperity with CO2 emissions, or from CO2 emissions. And so what that means is that, it's in large part the US, the first world, has been responsible for the vast majority of the emissions Now, you can't ask developing nations to give up development because it's not fair, it's not ethical, it's not just. However, if they can develop and simultaneously use less emissions for that development than the U.S. has, and then that other first world countries have done, then that's a good thing. So that is one thing that I think is encouraging, and hopefully those numbers will continue to come down. Now, if we think about how to decarbonize or reduce emissions, we have this issue where the cost of carbon dioxide emissions, the cost as far as warming, acidification, it's not included in the cost of purchasing and consuming fossil fuels. Basically, everything we do involves using energy, and that comes from fossil fuels. And so, there's kind of broad options. You can try and make fossil fuels more expensive, either by adding taxes to specific things or to carbon generally, or cap and trade schemes. You can try and make non-fossil fuel energy sources cheaper through research and development or through subsidies, and just displace them. If everything's just cheaper to use solar than an oil plant, then that's great. And finally, we'll talk about this a little bit. You could try to actively remove CO2 emissions. Right now, that's just a drop, not even a drop in the bucket, but might become important in the future. And realistically, for these categories, there's so many small things that you can do, and they have all pluses and minuses. But no one of them is going to fix this. So it's something where you need a lot of different things that will get you a little bit of the way there in order to try and fix this problem. So one thing that often comes up is this sort of idea of individual versus government action. So, what personal choices can you make to reduce your contribution to climate change? And then also, is it even reasonable to sort of think about it in that context? So there's been a number of people saying over recent years that, it's not even really fair to put any blame or responsibility on individuals, and that the idea of a personal carbon footprint has been pushed by large oil companies to muddy the waters and avoid large-scale government actions. I don't think that's, I think there is some truth to that, but I think it's important to consider what you do and how that impacts the climate, in large part because when we all collectively make individual decisions, then we make it easier for large-scale action to take. Not only can we have an impact on our own, but it's also a lot easier for leaders to lead if people are already heading in that direction. So this is a nice figure showing sort of relative trade-offs of saying upgrading your light bulbs from incandescence to compact fluorescence versus saying not having a car or having one fewer car available, all the way up to having one fewer child. Sort of thinking about the full scope of impacts that our day-to-day life has. Now, that said, we're not going to get there by individual impacts, and I think you should continue to live your life. Just you can try and make impacts either in what you do or how you do it. Now, if we think about government action, this is where we can make the most progress. So this is an example of both what I mean by lots of individual things getting us to our targets, and also something that you can play with on your own. So if you go to this energypolicy.solutions or just search energy policy solutions, you can play around with the impact of different policies. Say, making all of your electricity has to come from carbon-free. You're going to implement a carbon-free electricity standard and see what that does. You can mandate sales of electric vehicles. But what this shows is, so these are in emissions, tons, million metric tons per year over time, starting with present day. And if you have no changes, we sort of stay at those emissions. And each of these colors represents a different action. And if you add them all up, you get to a target. This is, I think, the U.S.'s emissions targets under the Paris Agreement. So you can see no individual thing here is going to get you all the way there. But taken together, and they add up. All right, so a few last things about some recent things. So one of the most encouraging things in the US in my lifetime has been the passage of the Inflation Reduction Act and a few other bits of legislation that passed in 2022 that are going to drastically increase investment in clean energy and vehicles in the US. So this is a figure from our article that Jesse Jenkins wrote. He's a climate modeler, tries to forecast out different policy changes that has U.S. emissions over time. So U.S. emissions have been decreasing over time. That's something that I think often gets lost, but they have been decreasing since 2005. Without the Inflation Reduction Act or the IRA, we were going to be about 28% down from our 2005 peak. With the IRA, if it's fully implemented, we'll get to a 50% reduction by 2035. So this is past our sort of current goals of 2030, but it's in making a huge difference in our trajectory. And I'm somewhat hopeful that with all this government investment, there's going to be a lot more add-on investment from private industry, and we've already seen that to some extent in battery plants being built and that sort of thing. So I'm hoping that we end up lower than this. But right now, President Biden has a target of cutting emissions in half from the peak by 2030. We're not on track to get there. We're about 5 minutes late, but it's substantial progress, which we haven't really had in a while. So, and then another thing is that globally in 2022, growth in renewables met 90% of increased electricity needs. So again, renewables are increasing and are making a real difference on how things are changing, but not enough yet. Okay, so just to end, this is sort of where we stand. You've all seen figures like this before, but it's good to go over it again. So we're in much better shape than if we had not done anything in the past. So with no climate policies ever enacted, we would have been in a range of 4.1 to 4.8 degrees C increase in temperatures by 2100. Our current policies have us between 2.5 and 2.9 degrees. So that's a lot. And no getting around, that's a lot. Huge impacts. With pledges and targets, so this is if people actually act on their pledges, some countries are on track, some are not, we would get to about 2.1 degrees C. Again, this is not, yay celebration or anything, but this is way better than it could be. Now we have a lot of work if we want to try and stick to a 2-degree pathway or even get back to 1.5 degrees C pathways. There's no shortcuts here. There is a lot that needs to be done. And time is not on our side, right? Every year that we delay emissions just makes it, that just punts the problem down another year, and we have to do that much more work to try and get to some of these targets. But we have made significant progress, and there's a lot more left to do, but I am somewhat hopeful that we'll get there. So that is where we're going to end off, and then we'll talk more about some strategies for geoengineering and whether or not that's even a good idea.